Alright, so here we are doing Chapter 4, Section 2. We're talking about using x and y intercepts. That's what our intercepts are. Our objectives are to find those intercepts, x and y, and interpret their meaning in a real-world situation. And then also use x and y intercepts to graph lines, because it turns out all you need is 2 points and you can make a line. Alright, so first thing, when you are going to use intercepts to graph, the y-coordinate of the point where the graph intersects the axis is the y-intercept, and the x-coordinate is always 0. So that's a very interesting thing about the y-intercept, is that the x is 0. The other one is that there's an x-intercept. It's where the x-coordinate of the point intersects the x-axis, and then the y-coordinate is always 0. So basically opposite of what you would think. X-intercept has a plug-in of y of 0, y-intercept has a plug-in of x of 0. And as you can see here, here is our y-intercept. It's being intersected by this point here, and you can see that the x is 0. Versus over here, we have our x-intercept, and in our coordinate point, the y is 0. Alright, so we're going to go ahead and interpret these graphs and finding those intercepts. One thing about the graphs that are usually presented in the curriculum we have is that a lot of times they will try to trick you with the scale of the graph. So, taking a look at this, they did only label every 2, and so yes, each coordinate is actually, or each grid line is worth 1 point. But sometimes they'll make it worth a half a point, or worth 4, or they'll count by tens or something. So just be clear as you're looking at a graph that you know what the scale is. So right here we have on the y-axis the y-intercept. And the y-intercept is going to be at over nothing, because of course your x is 0, and up 1. Then we have our x-intercept, which is over here. And our x-intercept is back to up nothing. Again, in our y-intercept, the x is 0, and in our x-intercept, the y is 0. So, we can also find, other than looking at a graph, the intercepts algebraically. So, as I kind of referenced to earlier, if we're going to find our y-intercept, we need an x of 0. So that means I can rewrite the entire equation and plug in an x of 0. If you plug in an x of 0, that means that 5 times 0 becomes 0, or goes away. Then from that we'll subtract 2y and have that equal to 10. Technically that means it's negative 2y equals 10, or since it's negative 2 times y, we could divide by negative 2. And we get a result of negative 5. So that means if we are trying to find the coordinate, that the y-intercept is an x value of 0, as we said it should be, and a y value of negative 5. The x-coordinate, the x-intercept, says that we need a y of 0. So if we rewrite the equation again, but then take out that y and replace it with a 0, we now have these pieces becoming 0, so 5x minus 0 equals 10. Technically that means 5x equals 10, or if we divide by that multiplier of 5, we end up with an x of 2. And so your coordinate, your xy coordinate, we already know y is 0, but x is 2. So that is how we find it algebraically. You either plug in an x of 0 or a y of 0. So remember that in order to graph a linear function or a line, you need to plot only 2 points. So you can't plot a line with just 1 point, because it's hard to tell what direction it's going. So the second point tells you, oh, we're going in this direction. And so that's how we know how to graph the line. So, again, you only need 2 ordered pairs, and how nice is it that there's an x-intercept and a y-intercept, which makes 2 ordered pairs that you can connect. Notice that it says the simplest ordered pairs to find are going to be the x and y-intercept, and that's because of, as you see in our previous example, we end up having this canceling going on. So you end up basically canceling anything that's next to the 0 that you put in. You can use a third point if you would like to check your line. So you either choose a point from your graph and check it in the equation, or you use the equation to make a point. So for instance, in this one, not in this one, but in this one here, as we were graphing, perhaps we would see on the graph that one of the lines intersects at a certain whole number. We could plug it in and check that it works. So this one here wants us to use the intercepts to graph the line described by the equation. So we're going to do just what we did in the previous and find the y-intercept by plugging in an x of 0 and an x-intercept where a y is 0. So rewriting our equation so that x is 0 simplifies your 3 times 0 to being nothing. Oh, how about I write that it's a 21 here. Then we divide both sides by that -7. And we end up with a y equal to -3. Meaning that our y-intercept is an x of 0 as we plugged in, and a y of -3. That means over here, 0 and -3, done. Alright, then we have our x-intercept, which again means that now we're going to replace our y with 0. So 7 times 0 instead of 7 times y. Simplifying, again, that means that this piece ends up canceling because it's 0. So we have 3x plus 0 equals 21. But that multiplier there is going to be divided. So that means that we'll have an x of 7. Officially, that means that the coordinate of the x-intercept is going to be 7, 0. So over 7 up nothing. If we connect these two lines as straight as possible, you could use the edge of a notebook or a ruler to do that. That is our line. Officially, what I would do if I was going to check this would be to pick one of these points that I have made on here. But of course, since my graph is a little off and I did not use a ruler, that's probably not the best to assume that, for instance, this is actually a point on the line, because it's actually not. Alright, so that is our 4-2 notes talking about using intercepts. Again, the opposite is true. To find the x-intercept, plug in a y of 0. To find the y-intercept, plug in an x of 0. And then just to reiterate that the up and down axis is your y-axis, and the across axis is your x-axis.